Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. I greet you and I welcome you specially to Prince Maths Clinic. Today, we shall be considering this very lovely and exciting Olympiad question, where we are to prove that x to the power of y is equal to y to the power of x. X is a number, y is a number. So let's go right into the solution. That's what we have on the board to prove. Let x be equals to a constant multiplied by y, where k is a constant and k is not equal to 1. So k cannot be 1. So what do we do? Now that we have said let x be equals to k multiplied by y, anywhere I see x in this question, I'm going to replace it with ky. Therefore, my x here becomes k multiplied by y, all to the power of y, equal to my y here is this, then my x is k multiplied by y. I'm going to take the square root of both sides. Now, taking the square root of both sides, I will have something like this. Then the next thing I want to do is to rewrite the square root. You know, when you have square root of x, is the same thing as x to the power of 1 over 2. I'm going to use that principle here. Therefore, this becomes ky, then this is raised to the power of half times y. And this will become y to the power of ky, all to the power of half. And we know from the law of indices that if we have b to the power of a in brackets to the power of c, it will become b, you multiply the powers, which is ac. Now, applying that here, this becomes ky, then multiply this by this, you have it as y over 2 equal to, this becomes y, ky over 2. Looking at this value, I can choose to rewrite it as this, y over 2 multiplied by k, so that if I multiply y times k, I get back my ky. Good. So this becomes ky, y over 2 equals to y, then I'll put the k here, carrying the power of y over 2. Now, what do you observe? You observe that the powers are the same. And in indices, when the power are the same, when the power are the same, the bases are equal. Or, in this case, you can multiply both powers by the inverse of the power. Y over 2 here will multiply 2 over y. Y over 2 here will also multiply 2 over y. So that 2 cancels 2, y cancels y in both sides of the equation. So I'm left with ky equal to y to the power of k. But like I told us, or like I told you, Once the powers are the same, you can equate the bases. So I prefer using that to save space on my board. I want to divide both sides by y. So y here cancels y. So my k here becomes y to the power of k over y to the power of 1. The bases are the same. And in indices, when you have a to the power of m over a to the power of n, as long as the bases are the same, you subtract the power at the denominator from the power of the numerator. So it becomes a to the power of m minus n. So you subtract the power of the power of the denominator from the power of the numerator. Good. So applying that here, this becomes y to the power of k minus 1. My aim is to find the value for y. I want y to stand alone so that I can find my x. So what do? I have to multiply the powers by the inverse of this k minus 1. So I'll multiply here and here, right? By the inverse of k minus 1. So this is what it will look like. So that k minus 1 will subtract k minus 1. Therefore, the value for y here becomes k to the power of 1 over k minus 1. Take note of this. That is what y represents. Putting this value for y here, hence x will now be what? K multiplied by y, and my y is everything I have here, which is k to the power of what? 1 over k minus 1. Mind you, the power for k here is 1, and the bases are the same. And we know that when I have a to the power of m multiplied by a to the power of n, as long as the bases are the same under multiplication, you add up their powers. So this becomes a to the power of m plus n. Here, I'm going to add up the powers. If I add 1 over 1 plus 1 over k minus 1, right? My denominator becomes k minus 1, and 1 in k minus 1 is k minus 1, multiplied by 1 becomes k minus 1, then plus k minus 1 in k minus 1 is 1. 1 times 1 is 1. But a more matured way to do it is the butterfly method, which I taught. You can search for that video in my playlist. Just say k minus 1 multiplied by 1, you get k minus 1. Then you say 1 times 1, you get plus 1. Then you say k minus 1 times 1, you get k minus 1. So you are obtaining the same thing. So minus 1 plus 1 will cancel out. So you are left with k over k minus 1. So this is the value for x. So this is what x represents. Recall that I said from the beginning of this lesson that x and y are numbers. So we want to try any number because they are real numbers. We are going to pick any number that we like. And remember, I said that k is a constant, right? And k cannot be 1. So let us try 2. Assume k equals to 2. Therefore, x will now become k, which is 2. Then the power, which is k, which is 2 over 2 minus 1. 2 minus 1 is 1. So I'll put 1 here. And 2 over 1 is still 2. So this becomes 2 to the power of 2. And 2 to the power of 2 is 4. Also, let us see what the value of y will be. Assume that k is 2. Therefore, y will become, my k is 2, 1 over 2 minus 1. And what's 2 minus 1? To give you 1. And 1 over 1 is still 1. And 2 to the power of 1 is 2. So what does that imply? Let us see if they are equal. X to the power of y means 4 to the power of 2 equals to 2 to the power of 4. Is this true? Yes, because 4 to the power of 2 means 4 in 2 places multiplied together. 4 times 4 is 16. And 2 raised to the power of 4 means 2 multiplied in 4 places, which is 2 times 2, 4, 4 times 2, 8, and 8 times 2, 16. So the value of 2, if k is 2, right? You can see that my x to the power of y equals to y to the power of x. Let's also try 3. If k is 3, so what will our x be? Our x will become 3 to the power of 3 over 3 minus 1. And 3 minus 1 is 2. And y will become k, which is 3 to the power of 1 over 3 minus 1, again, is 2. What does this represent? This simply means square root of, this could be written as 3 to the power of 1 over 2 multiplied by 3. Like I've always been saying in my class involving radicals, that what you have in the denominator talks about root, and in the numerator talks about power. Therefore, you can split this into this form, such that this becomes what? Square root of 3, then you power it by 3. And this simply means, so this is x, and my y is what? Square root of 3. So let's see if they are equal. So I can pick either this or this. I can pick either this or this. So let's test our value. X to the power of y is now 3 to the power of 3 over 2. Then y is 3 to the power of 1 over 2. Let's go. Equal to y is 3 to the power of 1 over 2 raised to the power of x, which is 3 to the power of 2 over 3. So how do we put a balance to this? Now, remember this figure is the same as 3 to the power of half multiplied by 3, right? I'll bring that 3 outside, right? Then this is times 3 to the power of half. Then this is 3 to the power of half. Put it there. Then here, what do we have? Raised to the power of 3 to the power of 2 over 3. Now, 3 to the power of half, what does it mean? It means square root of 3. So permit me to replace this with square root of 3. 3 to the power of half is square root of 3. Now, the power here is 1. And based on the law of indices again, once the bases are the same, you can add the powers. So if you add up 1 plus half, you get 3 over 2. So this becomes 3 to the power of 3 over 2. So if you look at it again, this equation is balanced as well. Let us pick the last value to try to see if this is true. I can hear somebody saying 7. Let's try 7. Now, if k equals to 7, what our x will now become 7 to the power of 7 over 6. That is 7 minus 1 gives us 6. And our y will become 7 to the power of 1 over 6. So let's go again. X to the power of 1 here becomes 7 to the power of 7 over 6 to the power of y, which is 7 to the power of 1 over 6. Then that is our left hand side. To the right hand side now, we have y, which is 7 to the power of 1 over 6, carrying the power of x, which is 7 to the power of 7 over 6. Now, if you notice, even in the examples, the figure when we picked 2, this base, the bases are always the same, right? So, and here, likewise here, the base here is the same. The base of the power is same with the base here. So, we suggest to us that we are likely to be correct. But looking at this critically, this can be rewritten as 7 to the power of 1 over 6. Then I'll pick this 7 out. Then multiply by 7 to the power of 1 over 6. Equal to 7, 1 over 6. Then here, 7 to the power of 7 over 6. Therefore, the power here is 1. So if you add 1 to 1 over 6, you will get 7 over 6, because this will become one whole number, 1 over 6. So 6 times 1, 6 plus 1, 7. So this becomes what? 7 to the power of what? 7 over 6. So which means the both of them are correct. So any value you pick for k will always prove to you that x to the power of y is equals to y to the power of x. So that, having done that, we can say that we have been able to what? To prove that x to the power of y equal to y to the power of x. So that brings us to the end of today's class, and I'm so sure that you love what you just watched. Kindly hit the subscribe button if you have not done so, and share this video with your friends. And more importantly, like this video so that the YouTube algorithm can promote this video and ensure that more people get to see what we are doing at Prince Maths Clinic. Till we meet again, bye for now.